Welcome, fellow explorers of the unknown. My name is Kareem Mohammed, and I invite you to journey with me into a realm so remote, so alien, it might as well be another planet. Imagine, if you will, a creature with no brain, no heart, no bones, a shimmering, gelatinous being that drifts through the eternal night of the deep ocean. And as if that weren't extraordinary enough, it glows in the dark, pulsating with an ethereal light of its own making. This is not a figment of some fantastical tale, but a living entity. That's the comb jelly, a real alien from the deep ocean, one of many such marvels that defy our terrestrial understanding of life. Down in the crushing blackness, where sunlight has never reached, an entire ecosystem thrives, populated by beings that have evolved in ways so bizarre, so wondrous, they challenge our very definitions of what life can be. Today we shall pull back the curtain, ever so slightly, on this hidden world. Prepare to be astonished, perhaps a little unsettled, but ultimately, I hope, filled with a profound sense of awe for the sheer ingenuity of nature. We will venture thousands of feet beneath the waves into a silent, cold world to meet some of its most enigmatic inhabitants. These are not monsters, but masters of survival, each a testament to the relentless creative force of evolution in the most extreme environments on our planet. So take a deep breath and let us descend. Our first encounter in this inky realm is with the Tanephor, or comb jelly. It is a creature of almost breathtaking delicacy, a translucent bauble adrift in the water column. Observing one is like watching a living jewel, its body often no more substantial than a whisper of jelly, yet perfectly adapted to its profound existence. They come in a myriad of shapes and sizes, from tiny spheres to elongated ribbons, each a masterpiece of minimalist design. The absence of a centralized brain or a pumping heart does not render them simple. Instead, it speaks to an alternative path of evolution, a different kind of biological success story, thriving in an environment where such structures might be a liability or an unnecessary extravagance. These ghostly drifters navigate their three-dimensional world with an elegance that belies their apparent simplicity. They possess no eyes in the way we understand them, nor do they have the complex nervous systems of creatures nearer the surface. Instead, they rely on a diffuse nerve net, a network of cells that allows them to sense their surroundings, changes in water pressure, chemical traces of prey or predator, the gentle touch of a current. It is a testament to how life can find solutions to the challenges of perception and reaction without resorting to the familiar biological architecture we often take for granted. Their very existence prompts us to reconsider what it means to be aware, to be alive in the grand tapestry of nature. One of the comb jelly's most captivating features is its bioluminescence. When disturbed, or perhaps as a form of communication or defense, many species can produce breathtaking displays of light. This isn't a harsh, sudden flash, but often a soft, rippling glow that shimmers along their bodies. Imagine, in the absolute, unyielding darkness of the abyss, these sudden, transient constellations of living light. The purpose of this cold fire is multifaceted. It can startle predators, lure unsuspecting prey, or even attract a mate in the vast emptiness. It is a silent, beautiful language spoken in a world devoid of sunlight, a fleeting spectacle of nature's artistry. Movement for the comb jelly is achieved through an ingenious mechanism. Rows of cilia, tiny hair-like structures arranged in bands along their bodies. These are the combs that give the Tanephor its name. Beating in coordinated metachronal waves, these cilia refract light, creating shimmering, rainbow-like patterns that ripple down the creature's form, even in the absence of bioluminescence. This is not just beautiful, it is an incredibly efficient means of propulsion in water, allowing for graceful, controlled movement as they hunt or evade. The subtle power of these countless beating hearts, as it were, propels these delicate beings through their dark, liquid universe. Despite their fragile appearance, comb jellies are voracious predators. Many possess sticky tentacles, or in some cases their entire bodies are adhesive, to ensnare small crustaceans, larvae, and other zooplankton that drift too close. Some engulf their prey whole, their gelatinous bodies expanding to accommodate their meal. They are a crucial link in the deep-sea food web, turning microscopic life into a more substantial meal for larger creatures, and in doing so playing a vital role in the nutrient cycling of these profound depths. They are silent hunters, efficient and beautiful, a ghostly, glowing presence in the eternal twilight of the deep. We now venture deeper into realms where the pressure is immense and the darkness absolute. Here we might, if we are exceptionally fortunate, encounter a true relic of prehistoric seas, the Goblin Shark. This creature is often called a living fossil because it is the sole surviving member of a family of sharks, the Mitsukurinidae, that dates back some 125 million years. Its appearance is unlike any other shark, almost nightmarish to some, with its elongated, flattened snout like a fleshy blade and its pale, almost pinkish-grey skin, a consequence of blood vessels showing through its translucent dermis. It is a creature that seems dredged from the very depths of time itself. The Goblin Shark's most astonishing and frankly terrifying feature is its jaw. Normally, its teeth are tucked away, but when prey is detected, these jaws can be protruded with incredible speed, shooting forward from beneath its snout to snatch unsuspecting fish, squid, or crustaceans. This remarkable adaptation, known as slingshot feeding, allows the Goblin Shark to ambush prey in the pitch-black conditions where sight is of little use. The jaws extend to a distance almost equal to the length of its snout, transforming its facial profile in a horrifying instant. It is a mechanism honed over millions of years, a biological marvel of speed and precision in a slow-moving world. Living at depths between 200 and perhaps over 1,300 meters, the Goblin Shark operates in a world where sunlight never penetrates. Therefore, its eyes are relatively small and likely offer limited vision. Instead, it relies heavily on other senses. Its prominent blade-like snout is covered with ampullae of Lorenzini, sophisticated electroreceptors that can detect the minute electrical fields generated by the muscle contractions of other living organisms. And it essentially feels for its prey in the dark, scanning the water with its snout, waiting for the telltale electrical signature of a potential meal before unleashing its lightning-fast jaw attack. The overall physique of the Goblin Shark is also indicative of its deep-sea lifestyle. Its body is flabby with poorly developed muscle mass, suggesting it is not a fast or active swimmer. This is common in many deep-sea creatures, as energy conservation is paramount in an environment where food can be scarce. Its fins are rounded and soft. It likely cruises slowly, conserving energy, relying on ambush rather than pursuit. Its ghostly pale coloration, too, is typical of animals that live beyond the reach of sunlight, where pigmentation offers little advantage for camouflage or display. Encounters with goblin sharks are rare, and much about their lives remains shrouded in mystery. Most of what we know comes from accidental catches in deep-sea fisheries. We know little about their reproductive habits, their lifespan, or their population numbers. Each specimen brought to the surface, however unfortunate for the animal, provides invaluable data for scientists striving to understand this ancient lineage. The goblin shark reminds us that the deep ocean is not just a habitat, but a repository of ancient life forms, a living museum of evolution's long and winding path. Our final subject for today is a creature whose name evokes images of gothic horror, yet whose reality is far more wondrous and gentle. The vampire squid, which translates, rather dramatically, to vampire squid from hell. Despite this intimidating moniker, it doesn't suck blood. In fact, it's not even a true squid, nor an octopus, but occupies its own unique order, Vampiromorphida, a living link to ancient cephalopods. It is a relatively small animal, typically growing to about 30 centimeters in length, a dark, velvety presence in the ocean's twilight zone. The vampire squid is a denizen of the oxygen minimum zone, a harsh environment at depths of 600 to 900 meters, where oxygen saturation can be as low as 3%. Few other complex organisms can survive, let alone thrive, in such conditions. Its metabolic rate is the lowest of any deep-sea cephalopod, a crucial adaptation for conserving energy in this oxygen-starved, food-poor world. Its blood contains a copper-rich protein called hemocyanin, which is more efficient at binding and transporting oxygen in low-concentration environments than the hemoglobin found in our own blood. It is a master of extreme adaptation. When threatened, the vampire squid employs a remarkable defense mechanism known as the pineapple posture. It inverts its webbed arms over its body, exposing the undersides, which are covered in spiny projections called cirri. This creates a formidable-looking spiky ball, with its vulnerable head and mantle protected within. Furthermore, it can eject a cloud of sticky, bioluminescent mucus from its arm tips. This glowing cloud can confuse and distract a predator for several minutes, allowing the squid to make its escape into the darkness. Unlike ink, this bioluminescent decoy is a precious resource used sparingly. Its appearance is truly striking. It has large globular eyes, which appear red or blue depending on the ambient light and the observer's perspective. These are proportionally the largest eyes of any animal on Earth relative to its body size, allowing it to capture every last photon of faint bioluminescent light in its dim world. Its 8 arms are connected by a fleshy cloak-like webbing, giving it its vampiric appearance. It also possesses 2 long, retractable sensory filaments, which it uses to detect food particles drifting in the water. These filaments can extend to many times its body length, acting like sensitive fishing lines in the dark. Contrary to its fearsome name and appearance, the vampire squid is not an aggressive predator. It feeds primarily on marine snow, a shower of dead plankton, detritus, fecal pellets, and other organic matter that drifts down from the upper layers of the ocean. It uses its delicate filaments to collect these particles, then scrapes them off with its arms and transfers them to its mouth. It is a gentle gleaner of the abyss, a testament to the fact that even in the most challenging environments, life finds a way, often in the most unexpected and beautiful forms. Its existence challenges our preconceptions, reminding us that names can be deceiving and nature's solutions are endlessly inventive. The comb jelly, the goblin shark, the vampire squid. These creatures are not from science fiction, conjured from the imagination of a writer. They are profoundly, astonishingly real, and they are hiding, thriving, in a world miles beneath the surface of our oceans, a world less explored than the surface of the moon. Each one is a marvel of adaptation, a living story written in the language of evolution over countless millennia in conditions of unimaginable pressure, perpetual darkness, and often scarce resources. They are real, and they're hiding miles beneath the surface in the vast three-dimensional wilderness that comprises most of our planet's living space. What we have seen today is but a fleeting glimpse into this mysterious domain. For every creature we have documented and studied, there are undoubtedly countless others awaiting discovery, each with its own unique solutions to the challenges of life in the abyss. The sheer biodiversity of the deep sea is staggering, and we are only just beginning to appreciate its complexity and its importance to the health of our entire planet. The ocean is not just deep, it's strange in the most wonderful sense of the word. It is a realm of perpetual surprise, a source of unending wonder. As we continue to explore its depths, we learn more not only about these incredible animals, but about the fundamental principles of life itself. The secrets held by the deep sea are vital, and it is our privilege and perhaps our responsibility to approach this hidden world with curiosity, respect, and a commitment to its preservation. Follow for more mind-blowing facts as we continue to unravel the mysteries of our incredible blue planet.